Hey guys, I decided to make a second video for the homework assignment, so I thought this might be a little bit easier. Okay, so in problem number one, we want to go from grams to moles, and in order to do that, we need the molar mass. So if I want to go from grams of ethane to moles of ethane, I want to cancel out grams by putting it on the bottom, and if I want to end up with moles of ethane, I'm going to put that on the top. So, before I do that, I need to know the molar mass of ethane, and there's 2 carbons at about 12 grams each, and there's 6 hydrogens at about 1 gram per mole each. So if I add that all up, I get close to 30 grams per mole. And I did my work ahead of time, so I wouldn't have to do it now. So 2 carbons is about 24, and 6 hydrogens is about 6. Add it all up, and you get to about 30 grams per mole. Remember, the 1 typically goes with the mole. And in this case, the 30.07 goes with the grams. So now we're going to multiply the top. So 6.75 times 1 is 6.75. And then we're going to divide by the 30.07 on the bottom. And my calculator gives me 0.2244. And let's talk about sig figs real quick. The 6.75 is going to limit me to 3 sig figs. So in my final answer, I'm going to round to 3 sig figs, so 0.224. Final answer. All right, I'm going to let you guys do letter B, but before you can do letter B, you need to A, write the formula for magnesium nitrate, and then B, you need to look up or you need to calculate the molar mass. And you will need to use parentheses for magnesium nitrate, okay? All right, so for number 2, same deal as number 1, except this time we're going in the reverse order. This time we're starting off with moles, and we want to end up in grams, okay? So moles of methanol are going to cancel out, and we're going to multiply by grams. And if I wanted to find the molar mass of methanol, we've got 1 carbon at about 12 grams per mole. We've got 4 hydrogens at about 4 grams per mole. And we've got 1 oxygen at about 16 grams per mole. And if we add those all up, we get to 32.04. Okay, I didn't show my work, but I kind of explained it. So 1 mole of methanol is 32.04 grams. So now we're going to multiply by the factors on top. So 0.035 times 32.04, and then we're going to divide by 1. And a quick word about sig figs. The 0.035 limits me to 2 sig figs. So 1.12 is just going to round to 1.1. Okay? All right, next one's going to be a little bit more complicated because now we're going to have to use Avogadro's number, and we're going to have to go from grams to moles to molecules to atoms, okay? And it can be a little tricky, so I'm going to do a couple examples here. All right, so step 1, we're going to go from grams to moles. And in order to do that, we need the molar mass of sucrose, okay? And I already calculated ahead of time. 12 times 12 for carbon, 22 times 1 for hydrogen, and 11 times 16 for oxygen adds up to 342 grams per 1 mole. Okay, so grams cancel out. And now we're in moles. But we don't want moles, we want atoms, and we have to go through molecules first. So 1 mole of molecules is equal to Avogadro's number of molecules, okay? And the last step, let's show unit cancellation of moles canceling out. We want to go from molecules to atoms. Now, we're going to have to go back and look at the original formula, okay? We've got 12 carbons, we've got 22 hydrogens, and 11 oxygens. And if you add it up, 12 plus 22 plus 11, that adds up to 45 atoms. So 1 molecule is equal to 45 atoms, okay? And so I'm going to use that as a conversion factor at the very end. 1 molecule is equal to 45 atoms. Now it's time to calculate. So starting with my 47.01, I'm going to multiply by 1 mole. I'm going to divide by 342.3 grams. Then I'm going to multiply by Avogadro's number. And I'm going to divide by 1. And then I'm going to multiply by 45 and divide by 1. And it looks like I'm able to keep probably 3 sig figs. Keep in mind that there's exactly 45 atoms per molecule, so this is not going to limit our sig figs. And if I do that, limit myself to 3 sig figs, I get 3.72 times 10 to the 24 atoms, okay? Remember, there's 45 atoms per molecule, and that's an exact number, so that's not going to limit my sig figs, okay? All right, I think the sulfuric acid is going to be the last one here. United States produces more sulfuric acid in terms of mass than any other chemical. How many moles is equal to 3.25 times 10 to the 10 kilograms? All right, so first thing I'm going to do is I'm going to start with my given amount. So 3.25 times 10 to the 10 kilograms. Now the problem is when we do molar mass, it's measured in grams. So we're going to have to go from kilograms to grams, and then we can go to moles. So 1 kilogram is equal to 1,000 grams. And how do I know that? Well, because metric prefixes. So at this point, we can cancel out kilograms. And the molar mass of sulfuric acid is 2 times 1 for hydrogen, 1 times 32 for sulfur, and 4 times 16 for oxygen. And when I add those up, I get 98.08. So 1 mole of acid is equal to 98.08 grams. So grams cancel out, and I should be left with moles, okay? So 3.25 times 10 to the 10 times 1,000 divided by 98.08, okay? Now, sig figs real quick. 3 sig figs, unlimited sig figs, 4 sig figs. It looks like I can keep 3. So 3.31 times 10 to the 11 moles of sulfuric acid annually. All right, guys, I know stuff's getting a little bit tricky. Don't hesitate to email me or send me a message. I miss you guys. I love you guys. I'll talk to you soon.